Okay, so welcome back. And now in this video, we're going to continue on and discuss how angles are related for the reference angle and some of the other quadrants. So if we look at here, so last time was this angle compared to being in this quadrant, and so we saw a relationship with that. But also we can look at the reference angle theta 1 to alpha, and we can put up a similar type of relationship by looking at the relationship between theta 1, theta 3, and alpha. And we see that since these are intersecting lines, right, so we've got the x-axis and this line here, we see that opposite angles are going to be congruent, they're going to be the same. But notice that to get from this angle to this angle, we just have to add 180 degrees to alpha 1 or theta 1. Okay, so but also we could take theta 3, we could subtract off 180 degrees from theta 3 to get to theta 1. Okay, and so all of these are connected in the fact that if we take a trig function of theta 3, that's going to be equal to plus or minus the trig function of theta 3 minus 180 degrees, which equals the function, the trig function plus or minus the trig function of alpha. Okay, now the only difference is going to be the sign depending on the trig function. And then also in the fourth, comparing the first and the fourth quadrant, again here you have theta 1, theta 4, and alpha. And so here we have the same points, right? x1 comma y1 and x1 comma negative y1. Okay, so it's a reflection across the x-axis. And so you've got these two angles are the same. And so if you add, now here's the thing, if you add 360 to theta 4, right, you get all the way around to this, right? So in other words, if you take 360 minus theta 4, you get theta 1. So theta, hold on. What did I? Yeah, that's right. Just want to double check. So the trig function of theta 4 is going to be the same, but it's going to be plus or minus, depending on the trig function, of 360 minus theta 4. Well, what's 360 minus theta 4? Well, 360 minus theta 4 is alpha 1, right? So, but alpha 1 is the same as, excuse me, not alpha 1, theta 1. Theta 1 is the same as the trig function of alpha. Okay? So again, these relationships also hold. So for example, sine of 210. So sine of 210, oh, I should write it over here. So the sine of 210 is equal to the sine of what? 210 minus 180, which is 30. 30 degrees. Okay. Which is equal to negative 1/2. Right? So 210 is in the third quadrant, right? And so if we have our rectangle here, we got negative x and negative y. Okay, and so in this case here, it's a 30-degree angle, so it's going to be 1/2, but it's going to be negative 1/2. So we can take any angle and make it into another reference angle, right? So this is comparing the trying to take any angle and make it into a reference angle, alpha. Okay. Now, what else? We've got, and you could do other, hold on a second. Oh, hold on. So this would be negative, I'm sorry. So negative, that has to be negative. So sine of 210 degrees, right, is going to be negative sine of 30 degrees. Why? Because 30 degrees here, right, 30 degrees is going to be 1/2, and then you're going to take the negative of that, okay, and you get negative 1/2 because you're going to the reference angle. What else can we do? How about tangent of 210 degrees? Well, if we do tangent of 210 degrees, so again, 210 degrees is over here. So if we do tangent of 210 degrees, okay, what do? We take tangent of 30 degrees, right? That's equal to tangent of 30 degrees. Okay, now, is it plus or minus? Well, that's where we go. We're in the third quadrant. Tangent is what? Positive in the third quadrant because it's y over x. But x and y are both negative. So tangent of 30 is going to be positive. So tangent of 210 is the same as tangent 30. So that's our reference angle, right? And so then we know that it's going to be tangent of 30 is going to be equal to 1 over the square root of 3. Okay? And so that's how we use the reference angle. Okay? And so these formulas are ways of seeing what the reference angle is going to be. And then again, we just have to remember what quadrant we're in so that we know what sign to use, positive or negative. Okay? So it depends on the trig function that we're using, and it depends on what quadrant we're in. And then once we have the reference angle, then it's just using the appropriate definitions of the trig functions. Okay, see you next time.